Okay, so I just finished up the heat shield on my turbine housing for my Garrett G45 1500, and it turned out awesome. I posted it on Instagram there, and I had a ton of people reach out asking me what materials I used, how I did it, and where I got all the stuff. So I'm here to explain all that for you. First of all, this stuff is super hard to find in North America, apparently. Amazon only sells the aluminum stuff, it seems. It's just hard to Google, like, what do you even call it? Well, it's called embossed stainless, and the best place I've found to purchase it is Stainless Bros. They also sell the Inconel version, but it's super, super expensive. I personally don't see it being worth it, but that part's up to you. So that's where you get that. I like to use a little bit of spray adhesive, and I use that just to tack up the ceramic fiber insulation a little bit for when I first start laying the insulation. Otherwise, it just slides everywhere. It can get really annoying to try to handle everything all at once. So just a little bit of that stuff goes a long way, and it'll honestly just vaporize off the first time that this sees any heat. So it's not of any contamination concern or anything like that, or a fire hazard. Just don't go absolutely nuts with it. Next, we have the ceramic fiber insulation. I like the stuff from this company. Chris from Unobtainium recommended it. It's just basically like fiberglass, but ceramic, and it's good for all of the temperature, like thousands of degrees Fahrenheit. So this insulation that I bought, I went with the 1/2 inch variety. I felt that that suited the turbine housing better for how much heat will be held in that thing. I would probably do a 1/4 inch variety on, say, things like downpipes or exhaust parts like the headers where you don't have the room for a 1/2 inch piece like that. So this does compress quite a bit. And like I said, definitely wear gloves when you're handling it, or else it'll get super itchy. Next, probably the biggest and most important tool of the whole thing is the spot welder. Now, it seems like on the internet, most of this information is fairly gate kept, and I don't know why. You really can't find a whole lot of information on it. So I just took some information from some various people and some videos that I saw, and we're gonna give this a go. Or sorry, I did give this a go. I got this bad boy off Amazon. I wasn't sure if 8,000 watts was gonna be enough, but honestly, like, most of the time I had it just on like 3. And if I was trying to do something crazier, I'd maybe go to 5, but I absolutely never needed full sauce. It's good to have the headroom though. Yes, it is super Chinese, and it doesn't look very trustworthy, but it works pretty darn good. I didn't have a single problem with it. The leads are really short, the spot welding leads, so that could definitely be lengthened yourself, I assume. The foot pedal is kind of cheesy and crappy, but again, it works. It's actually battery powered, which is kind of handy. So you just plug it into a little charger that it comes with, and then disconnect it, and you can just move this wherever you want. I'm sure this will come in handy for other projects in the future. I'm not sure what, but I'm sure one day I'll use it for something weird that I wouldn't have otherwise been able to do. So that's the main tool there. And then to cut the insulation and also to cut the stainless, I like to use these scissors. They're not that expensive, and they're like a heavy duty, higher grade tool made by this company called Engineer. I believe they're Japanese. Regardless, I have all of these tools linked in the description or bio there, both on Instagram, TikTok, and YouTube. Let's fire this thing up and see if we can't show you how the spot welder works. You just turn these on. They're pretty tiny, But basically all you do is have a little sheet here that we can weld together. Here we go. So, cut a few pieces of this. I hope this is in the focus there. If not, I'll do another close-up. And you basically just put both of these down and then hit the pedal. But if I do that on the metal table, it's just gonna weld itself to it. So let me find a chunk of cardboard. Sorry. You basically just overlap them. Go like that. Go like that. And for this, we'll just have it on like 3 to 4 would be totally fine. It's kind of cumbersome to hold it with both, or both of them with one hand, but it works. There. See those little dots? Come on, there you go. And that's all it is. You just do that a million times. I'll do a couple more here. And if you get too saucy with it, it'll basically just blow right through, but I haven't even tried it. Let's just crank it right up. See what happens. Probably just blow a hole in it. Oof, spicy. Oh yeah, just burnt a hole clean through it. She's like really on there though. Also watch out, this stuff is super sharp. It'll cut you. Ask me how I know. I also like to wear latex gloves when I'm working with this stuff. It's kind of fun to do, honestly. Ooh. There. All right, let's do some close-ups. Okay, we're gonna start low power. This is like level 1. Barely leaves a mark. Up a bit. So that was 3. That was perfect. Let's go too high. It's about 5. Still did pretty good. Let's go 8. Oh yeah, right through. Probably not what you want, but it's kind of fun. And just because, let's go all out. Yep, put another hole in it. So the sweet spot's about 3 to 5, depending on what exactly is going down. So that's basically how you do it. It's a super simple task. It's just kind of annoying and cumbersome to do it because you have to constantly just cut these little strips. So for this guy, I did one big strip of insulation all the way around it, and just slowly fitted these one at a time all the way around. Probably took me about 3 hours maybe to do this thing, maybe 4. But it was my first time and I'd be better now. But I'm pretty happy with how that turned out. I couldn't figure out a nice way to kind of get it held down in here. So I did tack it just a little bit to the turbine housing to keep the stainless from wanting to lift out and the insulation from coming out. I figured at least on the center section of the turbo, it's such a heat sink that it won't transfer much heat into the heat shielding itself. Also, this stuff can handle the heat that would transfer into it anyways from those itty bitty little spot welds. So I think it's fine. I'll find out firsthand. If it doesn't turn out, then so be it. I don't know. Comment what you think about that. Initially, when I had heard about that technique, I didn't love the idea, but as I started actually doing this, it made a lot of sense. See how she pans out, I guess? So that should give you enough information on how to do it yourself. If you have any questions about any of this, just, drop a comment. I'll respond. But it's pretty simple, honestly. And this works really well. So if you get all these tools, you'll be set up for success.